Hello and welcome. My name is Kathy Gibbs. I am a Senior Specialist Solutions Architect on Databases, and this webinar is going to be What's New in Postgres 11. So let's get started. So the agenda for today is why would I want to go to Postgres 11, why upgrade and choose Postgres 11. We're going to talk about partitioning enhancements. We're also going to talk about parallel enhancements. We're going to talk stored procedures, as well as adding new table columns with default values, and some general things as far as command line improvements and improved statistics. And then we're going to wrap up by talking about running Postgres as a managed service in AWS. Okay, so let's get started with why Postgres. Postgres is an open source project that started more than 20 years ago. It started from the same place as a lot of the commercial engines right now. It has an active and vibrant open source community that continues to innovate with new features and capabilities. This is partially due to the type of open source license that's used by Postgres, which allows anyone to modify the source code as needed. In addition, Postgres is not owned or controlled by a single company. It's owned by a nonprofit foundation which addresses customers' concerns about vendor lock-in. From the perspective of functionality, Postgres offers good performance out of the box, with transactional semantics very similar to those of Oracle and SQL Server. In fact, it's object-oriented and ANSI SQL 2008 compatible, which makes it easy for customers to migrate applications from other relational database platforms. It also has very strong support for geospatial capabilities with the PostGIS extension and supports stored procedures in many languages, including PL, PG-SQL, which is very similar to PL-SQL, which is Oracle's PL-SQL. This combination of features and capability make PostgreSQL the most Oracle-compatible open source database. And we even see that with our own schema conversion tool. It is the highest automatic conversion rates from Oracle to PostgreSQL. Many customers are telling us that they want to migrate some of their Oracle-based applications to PostgreSQL, and we'll talk about that through the presentation. Okay. This slide just shows you the evolution of Postgres. So you can see it did start earlier than 9, but just kind of without going through the entire history, that in version 9, we got streaming replication all the way up to 9.6 with parallelism and 10 in partitioning, and then we'll talk more to Postgres 11 as far as what the new features are going forward from there. I always like to find the common theme of a newest version of a database release. So for Postgres 11, what the common theme of is that not only does it have improvements to overall performance, but there are specific enhancements that are associated with very large databases and high computational workloads. So you can see the quote down below from Bruce Momgen, who is a core team member of Postgres, their global development group, that it is much faster, and we'll talk, you can see some of that when we talk to partitioning improvements as well as parallel improvements. Okay, so let's get started with partitioning improvements. So now we're going to talk about partitioning improvements. We're going to talk about these 4 topics. In Postgres 11, you now have the ability to partition by hash key. We're going to talk to data federation improvements, partition management improvements, and also query performance improvements, which is always something that's very important to everybody. All right, so partitioning improvements, that hash partitioning. As a general rule, you want to use hash partitioning for the following purposes: to enable partial or full parallel partitions with equal-sized partitions as far as to be able to join. You use this for partition pruning and partition-wise joins according to a partition key that's mostly constrained by a distinct value or value list. You can also use this to randomly distribute data to avoid I/O bottlenecks if you don't use a storage management technique that stripes and mirrors across all available devices. You can see here when you look at the screen that you create the partitions with the modulus, and that will give you the number of partitions. So in this example, I have 10 partitions across my table that I created. This table is employee. So you can see here, the next step, I've done a \D+, and it shows me the table. So I can see the table employees, and then I can see my 10 partitions associated with that. After I've created my partition table, I want to insert information into that table. The next row may be a little confusing because I have, after I've inserted 500,000 rows, if I do a select count from only the partition table, I'm getting 0 rows. That's because the partition table itself doesn't hold any of the rows. Those partitions are in each of the partitioned tables. So if you look to the second screen, if I do a select count just from that full partition tables, I see all 500,000 rows. If I select only from one partition, then you can see I've got about 49,000 in one, about 50,000. It's going to have data in each of those partitions, and you can see that they're around the same amount. Okay, now I want to talk to data federation. Data federation is another way to say that I'm going to shard the data. So I can separate my data and move the data when needed. So consider something like a customer banking application. Customers may want to retrieve data for that week or that month, but they rarely use the data beyond that. So I can move my partition to a different server and therefore possibly have lower costs for the storage of that data. So that's what we're going to do here. What you need to do is we need to include the extension, the Postgres foreign data wrapper, and that's what this is here. And then you'll create your table, and then we'll create the table on another server. So we create our partition table. You can see here mine is called customer data. And then I create 2 partitions within this partition table. My next step is to install that extension, Postgres foreign data wrapper, in my instance. The next step that I want to do is, now that I've created that foreign data wrapper, I want to create a foreign server that calls that foreign data wrapper. So I'm just creating this on what my foreign server is called, and I called it older data. And you can see here in the scripts, I've got to put in my host and what my database name is. Okay, so here's where the fun begins, actually, is where I'm going to go in and let's see what the next screen. I'm going to go to my older data server, and I'm going to create that partition table. Now I say the partition table here because in my new server, this older data server, it actually is going to be a full table. But in my first server, my primary server, it's going to look as a partition. Okay. The other thing that's smart, you don't have to do, but you can map my CRM user from my primary server to my older data server. That way I don't have to worry about does a user exist or doesn't a user exist. So you can see the SQL here to create the user mapping for that CRM user into my older data server. Okay, so once I've done this, now I've got that created. So if you can see, now I'm ready to create query. I can select from customer data. I can order by the transaction date, and I see all of my partitions, including my partition here, which is on my older data server. The next section that we want to go over is partitioning improvements for management. For me, this is really a lifesaver to have a default partition. This is something that if it's the end of the year and you've only created enough partitions that to last the year, then when you go into the next month, it might error out when you're trying to insert data, uh, especially on a range where I'm looking at from a particular date to a particular date. If I have a default partition, then that is almost a catch-all for not only myself if there was something where I didn't create those partitions, but also if there's some extraneous data that comes in. So it just makes partitioning management much, much easier now that we can have this default partition. You can see here that that's what this is, that I created my table finance as a partition table. Here's my finance partitions, and then I just created the default partition so I can put data in there. The second part of a partitioning improvements as far as management is that it is important to know that you do have the ability to create primary keys, foreign keys, indexes, and after triggers on the partition tables, and they will be passed down to all of the partitions. So it's important to know also where the problems lie with that, because if I'm creating a row level trigger on a partition table, it will cause identical triggers to be created in all of its existing partitions. So any partitions that are created and attached later will have all of those, but it's important if I've got large partitions, many partitions, that I would have a row level on each of those partitions. So most of the time that's good, but you need to be aware of that and careful so that you don't have an abundance of row level triggers. Both check and not null constraints are always inherited by the partition table for its partitions. Check constraints that are marked no inherent actually aren't allowed and they will error out. Also, you can only add or drop a constraint on the partition as long as there are no partitions. Once partitions exist, using an only will result in an error. So again, because we have to have that across all of those partitions, that's why that would error out when you get that. If you do have to do something along those lines, you would have to drop the table and recreate something with it. There is no way to create an exclusion constraint spanning all partitions. It's only possible to constrain each leaf partition individually. So while primary keys are supported on partition tables, foreign keys referencing partition tables are not supported. So let's talk now about query performance, which is very important, and I will be talking about performance throughout the presentation as well. Postgres 11 improves upon query performance when reading partitions by just using a new partition elimination strategy. Instead of looking through everything, it's actually going to do a faster partition pruning. So a binary search quickly identifies matching list and range partitions, and a hashing function will find the matching partitions for hash partition tables. So there's no more linear searching for partitions, and I have to linearly search and then eliminate. These partition pruning speed things up quite a bit. For partition pruning, think about subqueries, which can only be evaluated at execution time. Additionally, Postgres does support upsert. Now, upsert is one of those that can be controversial when people use it, but there are certain situations that upsert is going to save you a lot of time. And in that case, it's going to help you quite a bit. So if you think about I'm uploading a particular ID and I need to change the data or maybe even a bulk insert that happens, then I'm able to run that upsert functionality. Another thing that I think is really great about the partitioning is that you can have the ability to detach a partition or and how this can help is if you have a bulk load or a bulk delete, especially if it's contained in a partition. So I can actually do a bulk load to a partition that is detached. Once the data is loaded, then I can attach the partition. It just saves a lot of time as far as trying to, if I was otherwise trying to load data, it saves me time as far as for wall logs and for other users that are trying to query that individual table. It's also, when you do it this way, it entirely avoids the vacuum overhead that is caused by, let's say, a bulk delete. So let's go ahead and move on from partitioning onto parallel improvements. So here we're going to talk about parallel query performance. We're going to talk about B-tree index builds, which you can now do, parallelizing hash joins, as well as some general parallelizing gains that happened in Postgres 11. Okay, let's start by talking about the parallel improvement by parallelizing B-tree index builds. This is really great because instead of just having that serial build, which took a long time to build indexes, I can now parallelize that across separate workers. Generally, the cost mode automatically does determine how many worker processes should be requested, but you can change that. The maintenance work mem specifies the maximum amount of memory that can be used by each index build operation as a whole. That's regardless of how many workers processes were started. So if you've got a parallel index build, it may benefit from increasing this particular parameter, where if you look at an equivalent serial index build, would see little to no benefit. So this is a parameter, as you're playing around with this, you may have to increase. Another parallel improvement is parallelizing the hash joins. So this is a great way to look at it. Currently, and that means before 11, the inner side was executed in full by every cooperating process. So it built identical copies of the hash table, which could be very inefficient if it was large or say the plan happened to be very expensive. Now in 11, in the parallel hash join, the inner side is a parallel hash that divides the work of building that shared hash table. So you still do have that, but it's dividing the work. So things run much, much faster and can run exponentially faster depending on how big the table actually is. A great parallel improvement that comes with Postgres 11 is JIT, or it's just-in-time compilation. This is the process of turning some form of an interpreted program evaluation into a native program and doing so at runtime. So for example, instead of using a general purpose code that can evaluate arbitrary SQL expressions to evaluate a particular SQL predicate, like say where a.column equals 3, it is possible to generate a function that's specific to the expression and can be natively executed by the CPU, which yields a huge speed up. So now Postgres has a built-in support to perform that JIT, or just-in-time compilation, using the LLVM project. And at times, this actually can increase your performance in about 30%. Certainly, it's something that I've seen even as much as 10%. So again, it's not something that you want to use all the time necessarily, but where you can use the just-in-time compilation, or if you need a very big boost to large tables, long-running queries, things like that, that happen to be CPU bound, you're going to see a huge benefit from this. It is important to note that this parameter is off by default for Postgres 11, but for advanced users, and certainly you want to test that first, you can turn the parameter on. So let's just get to some general enhancements on parallel improvements. So PostgreSQL 11 can now execute the select queries that use union in parallel, even if the underlying queries are unable to be parallelized. So this just saves you time. If the underlying can't be, but the top level can, then you might as well still parallelize that. And that does happen in Postgres 11. Postgres 11 has parallel sequential gains as well, just built into the code. And there are several data definition commands that can either create tables or materialize views that can also run in parallel now. So they are parallel capable. It doesn't mean that they always will, but they have the ability if it's possible. And some of those are like that: create table as, select into, and also creating materialized views. So let's talk through some additional improvements. So let's start with stored procedures. Now, stored procedures in Postgres 11 is really big because what it allows you to do now is, like we mentioned before, for customers that want to migrate some of their databases off a commercial engine like, say, Oracle. In the past, you could migrate a stored procedure from Oracle into Postgres, but you'd have to change the code because it was similar to functions in Postgres. Now with Postgres 11, you can take that stored procedure code, including that create procedure part of the code, and you can migrate that into Postgres, and it now works instead of having to change kind of the code around it and the syntax around it. So developers have been able to create user-defined functions for over 20 years, but it wasn't able to manage their own transactions within the code. And that's the second part that's great about stored procedures, is that now you're able to have that transaction commit or abort within the procedure itself. Okay, a couple things to remember is just like about a lot of other things, you can't do things like commit something within the code and not outside, so you can't do independent outer transactions. There's no autonomous transactions, but you can create these procedures using different type of programming languages. So that create procedure command can be executed with PL PGSQL, which is the Postgres version, kind of that PL SQL that Oracle has, PL Perl, PL Python, or PL TCL. The next really cool feature about Postgres 11 is you can add new table columns with default values, and you no longer have to do a table rewrite when you do this. So this is huge, right? It's going to save you a lot of time, not only as a DBA, but it also saves your customers time as well. In the past, what I would have to do is I would have to rewrite that table, and that's going to give me, if a customer is trying to hit that table, they're automatically going to be locked out. So often I would have to schedule downtime to do this, or at the very minimum, I'd have to do this when my normal activity was very low in my database. Now I can do an alter table add column with a non-null default, and you can see here that it didn't change that. So I don't have to rewrite that table anymore, and it's a very, very quick process. Now, command line improvements, in some cases, there are features that at first glance seem really small, right? But they end up being larger than they look. This is one of those, especially for DBAs and developers that are moving from other database platforms, such as, say, an Oracle or a SQL Server, that I'm used to doing things a certain way. PL SQL's always been very friendly to the first-time user, and through various options like, you've got autocomplete that's there and shortcuts that are there. But the exception was always how to quit from PL SQL. I would try to do Control D or Control whatever and Control C and escape, and it would never let me out. You would have to do this \Q or Control D, which is not very intuitive to be able to run. Fortunately now, you can actually use the word quit or exit. So again, it's one of those things that as I'm learning Postgres as a former DBA from one of those other databases, it makes it just a lot easier for me to learn and to be able to work within PL SQL, or P SQL. The next, and one of the most important features that I have found in Postgres 11, being a former performance tuning DBA, is the improved statistics. So previously in versions before 11, while collecting optimizer statistics, most common values, so you call them MCV, were chosen based on their significance compared to all the other columns. But now in 11, those MCVs, or the most common values, are chosen based on their significance compared to most common values. So instead of having to scan everything, it's actually looking at that metadata and it's able to find information quicker. And therefore your statistics are going to run faster and you can get better statistics from that. Another is the improved selectivity estimates for greater than or equal to or less than or equal to, which is a really great thing when you're going through your particular code. And then they improved the optimizer row count estimates for exists and non-exists. So definitely improvements in statistics, and all that's going to do is hopefully make your code run much faster. So we've spent a lot of information on all of the cool new stuff in Postgres 11, but what about all that boring repetitive stuff that DBAs have to do to set up and manage databases? Well, that would be one of the reasons that you want to run on Managed Postgres. So just a brief history of Amazon RDS. So you can see really started S3 within AWS in 2006, and the first RDS launched in 2009. Really what I want to cover on this is that we do listen to our customers when we're coming out with new products and especially new RDS features. And you can see here, Postgres was one of those, as well as Amazon Aurora coming out and having that version. And we'll talk about that a little bit. But I wanted to show we continually add new features and continually add what our customers are looking for when we are coming up with new ideas. So the Amazon Relational Database Service, or RDS, is going to take care of those database functions that you don't necessarily like to do, so you can do all of the cool new things that we're talking about with Postgres 11. So failover, backup and recovery. We can do isolation and security, automated patching, and advanced monitoring, as well as routine maintenance and push button scaling. So if I want to grow, then I can do that through there. We do have a cloud native engine, Amazon Aurora. Open source engines you can see, and then commercial engines are all available through RDS. Of course, what we're talking about now is we're talking about Postgres. So you can see that we do have, we do the undifferentiated heavy lifting for you on these. Like I said, patching, backups, replication, and monitoring, they're very time consuming and can be cumbersome in the long run as your database needs scale. So with the routine work out of your way, you can focus on what truly matters for your business. So if you're a developer, you want to build awesome apps and you want to go try those new features, that new stored procedure in Postgres 11. If you're a DBA, you want your developers to make the most of your database by helping them design optimal schema, adding partitions, and where you can do parallelization. We mentioned briefly, you do also have Aurora PostgreSQL. So it is integrated with Aurora storage. And what does that mean when we have Aurora and it's compatible with PostgreSQL? Well, we started with the Postgres 9.6 code and have integrated Amazon's Aurora Cloud Optimized Storage into the lower layers. Amazon Aurora Storage maintains 6 copies of every write across 3 availability zones for high durability. It supports up to 15 read replicas with very low replica lag. It provides failover times of 30 seconds or less, and we're currently seeing more than 3 times performance gains versus PostgreSQL on standard benchmarks. So speaking of those benchmarks and that performance, we do have a tool called Performance Insights that does measure your database load. It does identify your bottlenecks. You can look at individual SQL. You can see where your wait is spending the most time. So if I have locking or I have CPU wait, that helps me determine how to do performance tuning. And Performance Insights is available on both Aurora Postgres and also on RDS Postgres. The other thing about the Performance Insights is you can retain 7 days worth of data for free. So in conclusion, today we talked about some of the top enhancements for DBAs and developers that are new to Postgres. Maybe they're coming from commercial engines as well as those people who have worked on Postgres for a while. Now this by no means is a complete list. There's a lot of new great things in Postgres 11, but I do find that the partition enhancements and then the parallel enhancements that we talked about really help out those people that are coming from other commercial databases such as Oracle, especially if you add in the stored procedures and being able to do that transaction control and having that create procedure syntax that's available to you. We talked about adding new columns, command line improvements, as well as improved statistics. And it is very important to note that Amazon RDS for PostgreSQL was released earlier this month. And all of the features that are talked about in this presentation are also available on RDS PostgreSQL 11. It's also important to note that we are targeting to add support for Postgres 11 to Aurora Postgres this year. Thank you for attending the presentation. Have a good day.